Welcome to STEMxx Chats interviews.
All right, well, Cecilia, thank you so much for joining me. Everyone, I'm happy to introduce Cecilia, who has a passion for material science and a background in aerospace engineering. She's a PhD grad student at UVA doing research at NASA. Cecilia, thanks so much for coming on.
Yeah, thanks for having me.
So I'm excited to talk to you today about what you're doing, how you got here, whatever tips you want to share with us. So maybe to kick things off, can you give us a little bit of a flavor of your job, about what you're studying, and yeah, maybe a little bit of catch of what's the most exciting part of what you do?
Sure. So I have the really unique opportunity of, even though I'm a PhD student at UVA, I get to complete most of my research at NASA. And actually the NASA location, there are a lot of locations around the country, but this particular location is NASA Langley, which if you've seen the movie Hidden Figures, that's the same location. And so there's a really great legacy sort of ahead of me at that center. But so my research was is to study 3D printing of aluminum for aerospace applications. So my day-to-day is, just depending on what experiment, I have everything from I have to do a lot of reading to a lot of experiments and then reporting on those experiments and analyzing the data and understanding what's happening. So it's really day-to-day is so different, which I really love about it. Sometimes I'm in the lab, with my hair up and a lab coat and glasses and gloves, and I'm working with chemicals and things. And then sometimes I'm at a microscope analyzing the samples that I prepared. Sometimes I'm sitting at my desk crunching numbers or doing image analysis and things like that. I'd have to say my favorite part of the entire job is using the electron microscopes. So there are different types of electron microscopes. The typical microscope you might be familiar with is the optical microscope, where we use light to see our samples. There's a type of microscope called the scanning electron microscope, or the SEM, and that's a microscope where we use electrons and they bounce off the sample and then they get picked up by a detector, and then that detector forms an image. And what I just love about it is how much closer you can get to the sample. So I can see things on the scale of microns, which is 1,000th of a millimeter. So it's a really tiny scale. And I'm so fascinated by that type of microscope because we can just see deeper and deeper. And I just took a class about transmission electron microscopes, which is the same idea, but instead of the electron bouncing into a detector, it goes through the sample because you make a really thin sample. And because of the way that all the physics works out, you can see down to atomic scale. So you can see like columns of atoms, which I just find so amazing. Like we can see the very building blocks of the materials we're looking at. So I hope to be able to actually use that microscope soon. But right now I just took like the theory class on it.
Yeah, that's so cool.
Microscopes are my favorite.
I agree. I think it's amazing when you start seeing things that are what you cannot see with your own eyes. Mm-hmm. It opens up this whole other world.
For sure.
So cool.
Yeah.
Very cool. Very cool. So what would you say are some of the opportunities that people in your field or people with your particular role right now have to make a positive impact?
I think there are so many, especially with material science, there's so much you can do with it and so many different places of application. So material science is really what you make it out of. Like any other engineering needs a materials person somewhere along the way. It's what we make our bridges out of, our cell phones, just anything that involves matter is really material science at the end of the day. And so in that way, there's sort of an abundance of impact and positive impact you can have, right? From making, like in my field where I work with aluminum and 3D printing, we ultimately maybe want to 3D print parts of airplanes or things. And so it's seeing if we can manufacture things faster. And ultimately faster means cheaper, which means that that money can be put into more research or different parts of the economy, and also to make things safer.
Very cool. So how did you get to this point?
Sure. I've always had an interest in STEM, starting from even before high school, really. I really loved math, especially. And I got into science kind of later. Math was really where I loved. everything. But I originally wanted to be an astronaut, like really passionate about being an astronaut. You'll see my moon poster behind me that like hung on the wall of my childhood bedroom. And I just loved astronomy. Yeah, and I was just really fascinated with NASA, especially. I was like the biggest NASA geek. But so I participated in a couple of really cool programs in high school that actually let me go to a NASA center and just see what life was like. So that was really special. And then heading into college, in terms of my major, I knew I wanted to work for NASA ultimately, but I didn't know what path would take me there. And so I was looking at different engineering majors, and I was kind of stuck between chemical engineering and aerospace engineering. And ultimately I chose aerospace. And so I did a major in mechanical and aerospace engineering. And then sort of halfway through college, I discovered material science. My university didn't have a major for it, but they had like a certificate program, which just means minor. And yeah, and so I also was doing NASA internships during the summers. And I had one of my internships, I had this really incredible pair of women mentors. And they just really changed how I thought about the field. You know, I went from sort of being scared, like, oh, science, like I used to think that science was kind of unattainable. Like you had to be too smart to be a scientist, or research, you know, it scared me because it was like, well, you're always asking why. And those kind of questions might, you know, it's kind of scary to be like, I don't know sometimes, you know, when you end the day and you say, I don't know. That scared me at first, but I had this mentor especially, and she was so technically capable, and just so humble about it too. Like you would ask her a question and she would just like tell you a super thorough answer. And then, I don't know, people in the department just really looked up to her and stuff and like would come to her for advice. And I was like, man, I really want to grow up and be like her. And so just having that mentorship role, and she's been, I still work with her today. She like coached me through my master's, and now she's helping me with my PhD. And I just really aspire to be as technically capable and as humble and like just a good person as she is. Yeah.
That's so awesome. Yeah, often like those key people in our lives make a big impact on us and what direction we take, and just having the confidence to really be able to pursue what we're interested in.
Absolutely. And that was, so I had met her when I was still an aerospace engineer, and I realized that the part of, like, in talking to her and seeing the research she did and stuff, it made me realize the part of aerospace engineering I loved so much was actually what we make it out of, like what we make the rockets out of, or the airplanes, and how we actually go about doing that. There's this new process that NASA was developing for making rockets, you know, like the cylindrical part of a rocket in one piece, instead of like welding a bunch of pieces together, which takes time, it's more expensive. You know, welds, we might not trust them as much as if it's just like one piece of material, you know. And so seeing that novel manufacturing process just really inspired me. And so actually I still finished college as an aerospace engineer, but then I got the opportunity to pursue a master's degree, which turned into my PhD. And I decided, hey, I think I feel confident enough to like switch to this thing called science, you know, and not just engineering. And so material science was where I ended up. So yeah, that's kind of how I got.
Yeah, very cool. And as you like look forward, you know, what are some of like the things that are most exciting to you, but then maybe like in the field in general, or like related to the field, you know, different avenues that seem most exciting?
One thing that I find really cool, so I do 3D printing here on Earth.
Here on Earth.
Qualifying that statement. No, because actually the type of 3D printer I use is called an electron beam 3D printer. And so what's cool about electron beams, you know how I was talking about those electron microscopes? It's kind of the same idea. It's like there's a theme or something. But so the electron beam additive manufacturing, that needs to be performed in a vacuum. So at NASA, we have a vacuum chamber the size of a room where we 3D print these materials to create the vacuum, you know, for the electrons. Because otherwise the electrons would just bounce off the air particles, and then you couldn't focus them to like melt the metal. And so this type of additive manufacturing is perfect for 3D printing in space where there's already a vacuum. And so I think that's just super exciting. Or the concept of like in-space manufacturing in terms of like welding structures together. So imagine at like here on Earth, you know, we build up a telescope, say, and we have to make it extra strong because when we launch it, it's going to be rattling around like crazy in the rocket as it's launching. And so, you know, if we could instead launch all the components, like maybe all the different truss structures, you know, they look like triangles and stuff. And if we could just launch all those components and then weld them in space, we wouldn't have to make the structure as heavy duty here on Earth, which would save weight. It would save time because we could just launch it all up there, build it up there for what needs to happen up in space. So that's something that's super exciting to me.
That's so interesting. And what about like challenges with that? You know, like something flies away or like, you know, what is, do you still need a little clean room up there? There's still particulates, right? Like, what does that look like?
I don't know the answer to the particulates or anything like that, but I know that in terms of like, if I'm trying to like weld two pieces of metal in space, here on Earth, you need really precise positioning to make sure, you know, if something's crooked, that could throw off your whole structure down the line, right? And so you have to really be precise about that. And so it's not just the welders and the material scientists getting ready to weld that joint. You have engineers preparing all those robotics and things to actually position things perfectly. So there's tons of challenges around in-space manufacturing, but I think it's a promising and really exciting field.
Yeah, it's really interesting. I mean, not having to deal with gravity and having that vacuum thing, that's really interesting. Yeah. You already shared a little bit about your day-to-day life. Is there anything in terms of like, as you look at your, maybe even your mentor who you mentioned, is there like a kind of a day-to-day role there that, you know, you've kind of seen a pattern in, and people who are like more senior in the field as well?
Yeah. So definitely as a student, and especially a PhD student, you have to do all your own data analysis. You have to do all your data collection especially. So that means I'm in the lab, like polishing a sample, you know, getting really hands-on, using acid to etch it so that we can see all the substructure and how it looks under the microscope. But as you get more and more senior, at least the way they do it at NASA, a lot of times that work is switched to a technician. And then as a researcher, you sit at your desk a lot more. So you might be reading a lot of papers, you'll be writing papers, or but you work closely with the technicians. Like sometimes the guy who works the microscope will call you over and, you know, have you look at what's going on. You might sit with him and say, oh, let's look at this area or that and that. But he's more specialized in just how to actually take really good images and stuff. But there are some researchers that I know who are more senior and they still do their own microscopy. So I think it's up to your interest. I definitely want to stay like doing my own microscopy. But I think it depends on interest and availability. Some of these researchers are on 3 or 4 projects. And so really, you know, I have the blessing of I get to focus on one thing and dive really, really deep. And they have to be able to juggle 3 or 4 different projects on possibly very different materials or very different manufacturing processes or things. So yeah, it definitely is. It'll be a different life the more I progress in my field. But I think I'm looking forward to it. Yeah.
Yeah, awesome. Very cool. And then in terms of the ethics, are there ethical questions that people in your field or in your role tend to encounter?
Yeah, the biggest ethical thing I can think of is actually more environmentally based. And so, you know, I was talking about using acids and chemicals to prepare my samples to look at them. But even like just depending on what materials you're using, the packaging that they can come in, you know, can be, you know, not biodegradable, like it could be a plastic or something. So in terms of like what materials we have to use to observe what we want, but then what's that stuff you throw away? You know, that I was talking to you briefly about that manufacturing process that makes a rocket in a single piece, or you know, portions of a rocket in a single piece. What's exciting about that technology is if you didn't make it with this special process, you would start out with a thick piece of metal and you would machine away most of it so that you get a thin plate with a little stiffener that's attached. Hard to explain. I'm sorry, I can't explain it better. But basically all that, you know, if my plate is this thick and I machine away most of it just so that I get this little piece poking up, right? That's a lot of scrap. And so I think ethically, the more that we can optimize our materials and our processing so that we can not be so wasteful, with scrap or with potentially dangerous substances going into the environment, I think is really important for our field. And then also just like, what materials are you designing? What are they going to be used for? Is it going to be used for good, or is it going to be used for something that might not be so good? And so I think just those are kind of some of the questions I think about often.
Very cool. Very cool. Awesome. So what advice would you give to the future of STEM? We have many people who will be listening that are in different stages of their career. Some who are just, excited to explore. Others who are, trying to make their decisions in what particular thing they want to study, or maybe, what role and what kind of company or what kind of industry. So what advice would you have for girls out there who are interested in STEM?
I think one piece of advice would be not to let yourself be too intimidated. I sort of talked about how I used to think I could never do science. It was too many whys, and I was just nervous I could never really fill that role. And so to just realize that there is a place for you, and to just, if you want something, to ask the questions, to pursue it, to study. Sometimes it takes me a lot of time to like sit and really study something before I feel comfortable asking a question and sort of putting myself out there. So I think just to be bold, and to not like to persevere, I think is important. And to just see what excites you. It might be that we're all not meant to be mechanical engineers, making cars, but there are so many places that are so exciting in the field of engineering and STEM and science. And so I love that there's just such diversity of topics that we can explore, and that there's a place for us in all of them.
Totally. Yeah, and it's so cool because you kind of learn these skills and these ways of approaching problems and of problem solving that then can be applied to so many different things, right?
Oh, absolutely. Like a great example is just with NASA. The original intent was maybe to make a tube of toothpaste to take to the International Space Station, right? But then that spawned off into new technologies, and now we use tubes for other things, and so the spin-offs from technology, it might apply to your daily life. Like someone invented a silicon chip, which first maybe wasn't thought that it would turn into your cell phone, but nowadays it's commonplace, and so technology sometimes may start for a particular application, but it'll trickle down and have a much bigger impact than you might think it will.
So cool. Awesome. Well, this has been really great. I also am wondering if you have any other interests or hobbies that you may want to share with people that are maybe outside of STEM.
One of my favorite hobbies is definitely baking. I think because of the precision aspect of it. So I love following really detailed recipes and just like things that have a lot of steps, because it's like, okay, if I'm going to make a croissant, right? I start with dough and butter, and then somehow I have to combine them and layer them. And so there's this special technique of rolling it out, folding it, refrigerating it, rolling, folding, refrigerating, and to create all those flaky layers, right? And then you have to cut them into triangle shapes and roll them up. And then you have to like be patient sometimes and wait for them to develop flavor in the fridge or things like that. And then you finally get to bake them and enjoy them. So I like the procedural aspect. Yeah.
So cool. Have you baked anything recently?
I've been baking a lot of bread, especially during quarantine. So that's been a lot of fun.
That's
great. I actually have some croissants preparing in the fridge right now. So I'm gonna roll them out today and bake them tomorrow. So
I love it. Awesome. Any last thoughts? Anything that comes to mind that we didn't get a chance to cover?
I don't know. I'd just say that STEM is an exciting place to be, especially right now with just how rapidly technology is evolving and all the different things you can do. And if you have the chance, check out scanning and transmission electron microscopes.
Perfect. Awesome. Well, Cecilia, thank you again. Best of luck with everything. It's good to talk to you.
Thanks for having me.
Thank you for watching STEM Chats interviews. STEM Chats exists to empower women in STEM. Follow us for more information, and if you would like to help us make this dream a reality, please get in touch.